Okay, for the two problems I have to do today are coming from 7.2 trigonometric integrals. As you can see here, these are the two problems I have to solve for. The first one is to compute for the indefinite integral of tangent cubed 2x dx. For the second, we have to figure out if cosine cubed x, the indefinite integral of that, is equal to cosine to the fourth of x over 4 plus our constant because we have an indefinite integral. Now we need to figure out, again, if this is true or false. So first, we'll start off with number 1. Compute tangent cubed 2x dx. Well, looking at this problem, we know from 7.2.4, which is one of the theorems that we learned for a strategy for evaluating trigonometric integrals, that if tangent is odd, then we can save a factor of tangent squared, and we know that tangent squared is equal to secant squared x minus 1. So this is going to be the indefinite integral of tangent squared 2x times tangent 2x dx. And from theorem 7.2.4, we know that tangent, let me put a box around this so it's not confusing, tangent squared x is equal to secant squared x minus 1. So from here, we'll do secant squared of 2x minus 1, because you have to remember we have this 2x here, times tangent 2x dx. Now, we need to distribute this tangent, so we're going to have tangent 2x times secant squared, and I made a little mistake here. This should be secant 2x minus 1, not secant squared 2x and minus 1 inside the secant. So that was my mistake. I just fixed that. So it's secant squared 2x minus 1. Okay, so let me just get rid of that. Okay, moving along. Secant squared 2x minus tangent 2x dx. Okay, so from here, we can distribute this indefinite integral over the subtraction. So now we have, this would be h of x is equal to f of x, which is going to be our first problem, minus g of x, which is going to be our tangent squared. So this is going to be tangent 2x secant squared 2x minus the indefinite integral of tangent 2x. Well, we know that tangent x is equal to the natural log of secant plus c. So in order to do that, we just u sub 2x, and we'll get du is equal to 2 dx. So now we'll have u over 2, tangent of u over 2 minus tangent 2x secant squared 2x. And then here we'll factor out this half, so then it will be minus 1/2, and then the integral of just tangent x, or excuse me, tangent u, is going to be ln secant u, and then this is going to be 1/2 of the natural log of secant of 2x. So moving back to this part right here, well, we know that we can u sub for tangent. So we'll do u is equal to tangent of 2x. So du is equal to 2 secant squared 2x. And this is because of the chain rule that we have this 2 right here. So now we will u sub, so we'll have, let me just do this. Now we'll have u secant 2x, and then this is going to be du under 2 secant 2x. So these two are going to cancel, and now you have the integral of u minus 1/2 ln and now if we factor out this 1/2, you have the integral of u minus 1/2 ln secant 2x, and then this integral is just going to be 1/2 u squared minus 1/2 ln secant 2x. Sorry, I keep forgetting that this is like that. So then we replace the u right here, so we'll have tangent 2x. So this is going to be now 1/4 of tangent 2x, and this is going to be squared, minus 1/2 ln secant 2x. Plus c, because we have indefinite integrals. This is going to be the final answer. Okay, moving on to the second problem. This problem is very similar to our first problem, and we also have a trigonometric integral strategy for this. We know that if cosine is odd, that we so then we can factor this also how we did the first one. So we'll do the integral of cosine squared x times cosine x, and then dx. From here, we know that if cosine is odd, then we save 1. So now we have this. And we know that cosine squared x is equal to 1 minus sine squared x. And this theorem is 7.2.1. And that is cosine squared x is equal to 1 minus sine squared x. So we'll do that here. We'll do 1 minus sine square x times cosine x dx, and we'll distribute in that cosine, so we'll have cosine x minus cosine x sine squared x dx. And as we did the last one, we'll distribute our integral, so we'll have the integral of cosine, of cosine x minus cosine x sine squared x dx. And we know that the integral of cosine is just negative sine x minus, here we're going to u sub for cosine. So u equals cosine x, write this up more on camera. My apologies for that. U is equal to cosine x No, that's wrong. I'm sorry. U is actually equal to sine x. And du is equal to cosine x. And we do this because if u is, when we take trigonometric integrals, we want to find out things that cancel so we can simplify our problem. So if this was cosine, then we just run into a bunch of problems later on, because sine would be over sine, and you would still have this cosine right here. Oh, excuse me. You would still have, yeah, you would still have sine squared x, and then you'd have to do it again. And so if we have u is equal to sine, then we have 2u, so u squared, and then du is going to be cosine x, because du over cosine x is equal to dx, which means that these two are going to cancel. So we have minus sine, negative sine minus u squared and du. And then the integral of that is just going to be negative, or minus 1 over 3. This is just going to be u cubed. Let's see, minus sine x. And then we plug in our u from here, so sine x is just going to be this. So 3 sine cubed x minus sine x plus c, because it's an indefinite integral. Should probably do plus c here. And so we noticed that this is our final, and that does not equal, so cosine cubed x does not equal cosine 4x over 4 plus c. So we now can conclude that this is false. And if you wanted to check this, then you would take the derivative and you would get back to that. So that is it. Thank you for tuning in, and hope this video helped you out. So thank you.